Thank you. Thanks, Srini, and thanks very much for inviting me to share my thoughts on the machine learning model development lifecycle. I'm very excited to be here, and good afternoon to all of you for joining this presentation. So as I was thinking about what topic to sort of share with Srini for this forum, I felt it would be important, as many of you are planning to either do an internship or do a full-time job, that maybe exposing you a little bit to some of the practical requirements when you actually build a machine learning model might be more useful than talking about maybe machine learning modeling techniques, which I'm sure most of you are very familiar with based on your curriculum, either by taking machine learning specific courses or other courses that are related to machine learning. So that was my sort of objective. I hope you find this useful. So without much ado, let me just jump into the presentation. So just a little bit on Wells Fargo itself. Wells Fargo is a very large bank. In fact, to sort of see how large it is, 1/3 of every U.S. household has some kind of a relationship with Wells Fargo. So that's the level of our footprint in the U.S. market. And we serve all kinds of customers, both retail customers, commercial, as well as wealth and investment management. And within Wells Fargo, I belong to an organization called the AI Center of Excellence. And as an AI Center of Excellence, what we do is we run this organization like an internal machine learning consulting team. So we work very closely with our lines of business partners to identify potential opportunities where machine learning and AI can be applied. And then we mature those use cases, and then bring the relevant data for building those models, and then use different kinds of modeling techniques to address those business challenges. And then finally also work with our AI technology partners to deploy that model. So that way, we are involved in the end-to-end life cycle of the model from the beginning, where the opportunity is identified, to delivering the model so that the business can realize value of the model. So that's what we do. And in terms of agenda for today, what I was thinking is I will spend some time talking a little bit about the banking landscape. I'm sure some of you are familiar with what a bank does, but some others may not be. So so to sort of ground on that topic, so I thought I'll talk a little bit about banking itself. And then also talk at a slightly higher level on some of the broad modeling areas in banks. After that, I will talk about the model development lifecycle, which is the core topic of today's presentation. And I will also talk a little bit about the operating model. An operating model is something that is used to execute on something. So how do you execute on the model development lifecycle? So that's also something that I will be talking a little bit today. And then we will do a sort of a mini workshop. I know we don't have a lot of time, but I want to expose you to a practical problem, and love to hear from all of you in terms of how you would go about tackling this particular use case. And then finally, would like to talk a little bit about our quant program, both internship as well as full-time opportunities coming up. And then I'll open up for Q&A. Having said that, if you have any pressing questions that you want to ask me when I'm presenting, feel free to interject. Okay. So, all right. So first topic on the banking landscape. So what do banks do? The main role of banks is to be sort of the intermediary, right? The financial intermediary between customers who would like to park their money in return for some services, and customers who want to borrow money for some economic activity, right? So that's the main role of banks. And banks play a very critical role in the economic development of a country in terms of how money transfers are happening, so that people who have excess money are able to gain some benefit out of it, and people who need to create value out of that, they're able to borrow money. In addition to that, banks also take money from the Federal Reserve or the federal government as a way of driving some economic stimulus. Coronavirus is a great example, right? So because of this has produced a lot of hardship to different people. And the federal government has disbursed a large amount of money through stimulus packages, and they need banks to be able to transfer that money to the people in a very responsible way, so that the benefit from these things goes to the intended people. So that's, in a nutshell, that's what banks do. And broadly speaking, large banks like Wells Fargo, we have three major functions. First one is the consumer or retail banking. So this is for individuals like you and I, right? And as well as some small businesses. So that's what this area of the banking does. And some of the services they provide are opening up savings or checking accounts, providing a debit card, doing online bill payment, and then a whole bunch of other services when you open these accounts and deposit some money. On the other hand, they also use all of these funds to loan money, and they do loans for various things. They offer credit cards as an unsecured loan. There is mortgages, auto loans, student loans, and a whole bunch of different lending products for people in need of money. Okay. So that's what consumer banking does, and it's a very large portion within at least Wells Fargo. And some banks have concentration in some of these areas over others, but as far as Wells Fargo is concerned, our big focus is on consumer and retail banking. The second one is wholesale banking. It's also sometimes called commercial banking, and this is very similar to consumer banking, except that the deposits as well as the lending relationships are with companies. So it does have a slightly different flavor to it in terms of the type of products one offers, the type of services they offer to people who park their money and things like that. But in its spirit, it's very similar to how consumer banking works. The last one is investment banking, wealth and investment banking. These are services the bank offers for both individuals, retail customers, as well as commercial customers, for helping them either grow their wealth or create opportunities for getting additional funding through capital markets. Okay, capital markets means either equity, where you try to help a company go public, right, through an IPO offering, or by releasing bonds, right? So banks help these clients to set up these things properly so that they can get maximum funding. In addition to that, they also do asset planning for individuals. They help, and then of course they help individuals with different tiers of wealth. You have people with lots of money. Then you have different types of products for those types of customers. And there are others who may not have a lot of money, but they will be interested in buying certain types of bonds or treasury instruments and other things, and the banks will be able to provide those types of services for them. Okay, so in a nutshell, these are the three areas: consumer banking, wholesale or commercial banking, and wealth and investment management. And through these transactions that the banks have with different types of customers, the banks actually generate a lot of data. So that is the origination of data. Those are the source of data, and sometimes these data sources get collected in what is called as source data systems, based on these transactions with customers, and then all the data from these different source systems get aggregated into large databases. That then flows through downstream applications around reporting and machine learning modeling and a whole bunch of other activities. Okay, so that's sort of a high-level view of how banks are structured and what banks actually do. Moving on, here is sort of the high-level, again, overview of the types of modeling applications or modeling areas that banks are involved in. So the first and foremost is credit risk, and this is a super important area in the bank, because when you deposit money in a bank, you trust the bank to take care of the money really well, to pay you interest, to provide you the services that they have promised. But also, you expect the bank to be responsible lenders. So what this means is, after you lend money to somebody, you have to continuously monitor, their credit risk. The credit risk means what is the probability that somebody may not pay the money that they owe the bank, okay? What is the probability that you will not make your next credit card payment? What is the probability that you will not make, your next mortgage payment? All of these types of models comes under the broad category of credit risk. And it is very important. It's important for us to manage credit risk, knowing that definitely always when you lend hundreds and thousands of customers, you're definitely going to see some defaults. But then in the bigger picture of things, that risk should not become too big to the point that it becomes a problem for the bank. So that involves, responsible lending, managing those credit risks, and then doing any kind of mitigation strategies that will be needed. For instance, if somebody is not paying their credit card, then what is the strategy that we need to apply? First, we need to predict that this person is likely to not pay the credit card balance. And then maybe, somebody from the bank will give a call to this person and say, hey, what's going on? Do you have any issues? How can we resolve this? And things like that, so that proper payment is made, okay? So that is the broad area of credit risk. Then second one is credit decisions. It's very closely tied to credit risk, but the only difference here is credit decisions are made before a customer comes into your book of business. So this is the risk at the time of making an application. It could be a credit card application, it could be a mortgage application, student loans, auto loans, anything. The bank has to make a decision every day, okay, on whether to take a person into their book of business or not, based on all the information that they have. And this is also, there are a lot of different types of models one would build for this. But a unique sort of a distinction between credit risk and credit decisions is when you do credit decisions, you've got to really think about a lot of external data that you need, because you don't have this customer in your book of business. You don't know much about the customer. So you have to learn a lot of these things and make those right predictions based on all the information that you can get from outside. It could be, credit bureau scores, and it could also be self-reported values, as well as other verifiable accounts like a pay slip or, other outstanding loans and things like that. So that's the second one. Third one is once the customer comes in, there's going to be all of these transactions, right? Every day you're moving money in and out of the bank, you're making some payments. And you're also having some needs. I mean, you're fluctuating. I mean, your credit balances might be, cash balances might be fluctuating in your account. So it's important for banks to sort of observe those things and offer some additional enhanced services for customers. For instance, the bank might, observe that your balances are steadily increasing, but your expenses are increasing. And in which case they might call you and say, hey, maybe you have to shore up your credit so that you can take care of some of the future expenses that you normally have. And that applies to businesses as well, right? So when a business is parking money in a bank, one of the things that they use it for is to buy some products, right? So businesses are always buying something and then selling it to someone else. If the cash balance drops below a certain level, then it impedes their ability to do their business in a very fluid, streamlined manner. So banks can intervene there and give them some additional credit products to help them shore up their balances so that they can continue doing their business in a smooth manner and be very profitable. And then because of the fact that there are all these transactions and you have lots of customers dealing with money, right? You always have a risk of fraud. And that happens every day. There are people who are skimming off money through credit cards, who are transferring money to different places that they're not supposed to transfer. And so every day, the banks have to tackle this problem that happens, and these patterns change very frequently. If you try to stop one type of fraud pattern from happening, there's suddenly another one that is happening. So there's always this catch-up game where you have to constantly improve your models to detect these things quickly. So on the financial crime side, broadly speaking, there are three things that the bank worries about. The first one is is really around detecting a fraud from happening. That is, the transaction has already happened, and then you want to detect if this is actually a problem. If it is a problem, then you want to stop the transaction so that further losses are avoided, and then take mitigating actions in terms of recovering the loss, right? So this is a way of protecting our customers, the bank, and quite honestly, even the economy, right? I mean, the fraud, if you let fraud go without any control, then it can eat into the economy. The second one is called prevention. Prevention is trying to do things so that even a fraud doesn't happen. For instance, you can block, very suspicious merchants, right? Certain types of merchants, you don't even allow your customers to transact with them because you have preponderance of evidence that, there's a lot of fraud that happens in these merchants. Or the same thing with anti-money laundering. The United States government has something called the sanctions list. The sanctions list is updated on a daily basis. It basically says who are the people who can legitimately transact with the bank, right, in the financial system, not just with Wells Fargo, but across all the banks, because wire transfers go from different financial institutions. And so if we have those sanctions lists, then we can proactively, predict certain patterns and block, these individuals or entities from transacting through our financial system. So that is prevention. And the third one is called claims handling. Claims handling is when a bank doesn't realize that even a fraud has happened, it has not detected or prevented it, so it has come through. And then the customer realizes that this is actually a fraud. And I'm sure that it must have happened to some of you where you see a fraudulent transaction on your credit card. Obviously, the bank has not detected that. So you call the bank and say, hey, this is not a transaction that I made. This is fraud. So you are claiming that it's fraud. So the bank has to, so you're making a claim, and the bank has to now respond to that by doing some verification on their side to determine if this is actually legitimately a fraud or not, and then quickly respond to the customer to take care of the situation. So there is a wide range of problems for different types of products for all of these three areas, which is detection, prevention, and claims handling. And then another very important area is fair lending. Fair lending is a very big thing because the government, especially around the lending side of things, when you lend money, sometimes it's easy for us to lend money to the people that we think is going to be less risky, right? It could be lending money to only the rich people, or it could be saying that, hey, I'm going to lend money to only OR professionals or AI professionals who are guaranteed to have jobs for the next 20 years. This is a great market, so I know my money will definitely come back to me, so I'm going to lend only to these people. That's not a good strategy for the bank because it results in concentration risk. But it's also not good for the country because the idea is having some level of equity in the lending process, where disadvantaged people also get an opportunity to borrow money so that they can improve their lives. So banks, being a financial intermediary for the government, need to be very responsible in terms of how they lend. So we always have to be asking questions when we reject an application for a loan. Are we doing the right thing? So that is very important. It's not always profitable. Profitability is not the most important. It's must ask the question, are we doing the right thing? And models are in the forefront of these things nowadays. So if you look at AI models, one of the big areas right now in terms of discussions that's happening, a very hot topic is fairness, bias, and explainability. You need to ask your question, is the AI model having some kind of inherent bias? And oftentimes this stems from the data that you used for training, or some of the assumptions that you have made during the modeling process that can result in some of these biases. So those biases have to be corrected. So those are all things that comes under, broadly the fair lending space. And, many of these things are also interrelated. And another area is the operational risk space. So what is operational risk? So all the things that we have seen so far, all these transactions and things that we do for our customers, they happen through tens or even hundreds of different systems. Some of these things are large systems that are enabling all of these transactions to happen. And if one of these systems, for whatever reason, they fail, let's say it's a fraud detection system. And if the fraud detection system fails, it can result in significant loss, not only for the customers, but also for the bank. And it can expose us to additional risk. So it is important for us to recognize under what situations a system like this can break. That is one. Second one is, how do we mitigate this, from happening in future? And the third one is, if it happens, what are our backup plans, right? So it's important to have some kind of a parallel system that can take over and things like that. All the things around the processes that are involved around making sure that there is this full continuity in terms of the business process that we have is sort of, in this area of operational risk. So those are some of the broad areas that we focus on, and obviously all of these things result in a massive amount of data exhaust, including unstructured data like text, voice, and images that can be further used to give additional insights so that we can serve our customers better. And then a little bit on the techniques. Here I have split this into statistical econometric techniques versus ML/AI, and I know that sometimes some of these things are a gray area, right? Like for example, unsupervised learning. Obviously, some people and it's right to say that these are all machine learning techniques as well. So we use a broad range of techniques for addressing some of for building models for some of these areas. Machine learning techniques are being increasingly used as well because of the significant nonlinear approaches that can be used using some of these techniques, and obviously provides a significant level of great quality of predictions to these models. In terms of the techniques and technology that we use for machine learning, largely it's Python. Okay, Python is the pretty standard thing that we use. But for a lot of these statistical models that we build, we use SAS and R extensively. And for large data sets, having some knowledge of Spark technologies like PySpark, it will be a really good thing because you will be invariably working on big data environments like Hadoop and others. So having that knowledge is super important to be able to manipulate large data sets. Okay, any questions so far? Okay, so let me move on to the next one, which is our core topic of today's discussion. So I'm going to start this topic with a visual, all right, just to motivate as to why we need a model development lifecycle and what it is. So let's think of a hypothetical business problem for which you're trying to build a model. So there is going to be a project kickoff where you're going to understand the business problem, and roughly that this can be tackled with a machine learning model. So once you have that, typically during this time, you will also have a sense for what does model completion really mean, right? What is that going to be, that ultimate deliverable? So these two things are, generally clear at the very beginning of the project. Now, just let's assume that there are three different, sort of a data science or machine learning teams that are working on this project. Then it is possible that the first team that works on this has taken a pretty, smooth and very streamlined approach to solving this problem. They have really thought through really well in terms of what data sources we need to build a model, really thinking carefully about how the business is going to consume the model, so that they're thinking already about the integration aspects of the model, and as well as some of the other considerations around what kind of labeled data that they will need and so on. So they're really very well thought through at every stage of the project, and they've been able to execute this thing really well. It is possible that another team that tried to work on this project took a little bit of a zigzag approach. Nothing wrong with this in a very exploratory setting, like for example, when you do in universities, maybe even this is preferred because this gives you an opportunity to look at so many different things, right? Maybe you started off, approaching this model, thinking that, a small amount of data is okay to make good predictions, but then very quickly you realize that is not true. So you did a pivot and then said, okay, I need more data. And then so you went on and did, try to spend additional time discovering and getting additional data, and then maybe tried a different modeling technique. Maybe you started with reinforcement learning as the best possible approach, which might be great, but it's also a very complicated approach. And you might very quickly recognize that maybe you should have started with something simpler. So you again pivot to do something simpler, and then do all these switchbacks, right, till you finally get to the model completion. So this path is fine in a sense. You have achieved the model completion successfully, but you have taken a lot of zigzag paths, and because of which you have taken a lot more time than what probably was necessary for solving this model. So that could be another experience, right, with another team. And the third one is the case where a team is making steady progress. They're making all the right assumptions initially, but somewhere down the line they make some bad assumptions and they go off on a tangent. So they're making steady progress, but in the wrong direction. So they're not hitting the target, which is to meet some of the goals of the project. and then this would be problematic, right? So they have maybe taken a very fancy technique and made some assumptions on data without consulting the business, and because of those assumptions, they end up with a conclusion that is not aligned with how the business can use the model. So this type of thing also happens. So this is not a desirable thing, right? So how do we actually bring some level of conformity in terms of how different teams go about building models, while at the same time giving them the flexibility to try different things? Because that is the sort of the core of machine learning models. You need to have the flexibility to try different things, but at the same time you need to have some conformity, because in real world, when we are building not one model, so in your curriculum, when you're building a model for a project, you can explore a little bit here and there, a lot of different things. Some of these things may not even work because you're just building a model just for yourself, and it's just one person, right, for that project. But in a company setting where you're building hundreds of models to deliver value, somebody has to make money or save cost or something else, right? There has to be tangible benefit coming out of this, and somebody is spending money to build these models. It is important to hit certain timelines. You will have to commit to certain timelines and work in a very parsimonious way to be able to do some of those things. So in order to bring that level of conformity, this model development lifecycle is required. So model development lifecycle is really, you can think of that as a set of guideposts. Okay, so between project kickoff and project completion, you come up with a certain set of guideposts where it doesn't matter which team is working on this project. Everyone has to actually pass through each of these guideposts. And so if you actually set up these guideposts in a way where you do not have too many of them, too many of these guideposts or too few, then you can bring in a certain level of structure to how models are developed and delivered to the business. And that will mean that, while there is still flexibility in terms of how you actually build your model between guideposts, okay, so that gives you some ability to explore different things, you are still going to have to hit some of these guideposts, bringing that level of conformity that I was talking about, okay? So the key thing for us is to understand why we need these guideposts, because we cannot simply come up with guideposts without having any rationale. It has to be very meaningful and logical for somebody to be able to hit these guideposts. So it has to be very clear as to why we need this. And it is also important in a company setting who's going to be responsible for delivering whatever needs to be delivered at the end of this guidepost. Why that is important? Because in a company setting, you're not going to work on a project just by yourself, or for that matter, you may not even be working on a project just with a set of people with your same skills. So when you work on a project in your curriculum, even if you're not doing it by yourself, you're likely to work with your buddies or others, and all of you have very similar skill sets. In an industry setting, you're going to be working with people from very different backgrounds. There might be a business analyst, there'll be a data subject matter expert, there'll be a line of business subject matter expert, and others, project manager, and so on. So it is not just people with just the same set of skills. So you got to be able to work with all of them. So it's important to understand who's going to do what in the project. Okay. So in my presentation, I'll be going through some of these guideposts in the next couple of slides. And I'll be mostly focusing on the first one, really trying to motivate you to see why we need this. Okay. And another important aspect is between these guideposts, as you're working on this project, and especially when it comes to machine learning model development, there is a lot of uncertainty that is involved while building a model. You might start with some data and then later on realize that the target is not well defined. So you may actually have to have a discussion with the business, and you may actually have to do some course correction based on it. Or you might find that you have the data, but the data is not sufficient. There is an important data source that somehow you're missing. The business partner let you know later. So you have to react to that and be able to bring the data in and still make progress, right? Or you could have taken a slightly different approach and then later on found that although the approach is good, you may not be able to implement it the way you thought initially you would be able to implement because of some technology constraints or other similar constraints. again, you have to react based on all of these uncertainties that are coming your way and be able to make some course correction and still be able to come up with that minimum viable product that can be useful for the business and then iterate on it to improve it, right? And because of this, you really need a flexible methodology, a flexible project management approach, if you will, right? Traditional project management, you would right at the beginning of project kickoff, there will be a project manager who will sit with you and say, okay, guys, what are all these different tasks that we have to accomplish in order to hit this final milestone, which is model completion? Unfortunately, that traditional approach doesn't work because you may not know all the things here at this point, and you have to react on the fly as you're working on the project. You got to, come up with new set of tasks that you want to complete, and then react to any uncertainties based on that. Okay, so I will be talking more about these guideposts and also briefly touch on this flexible methodology, which I'm sure some of you know is called the Agile methodology. And so I'll basically not really get into the details of Agile methodology, but basically show how a team is structured for Agile model development. And just to go back to the original topic of this presentation, the reason I also wanted to share this was because this is something that is normally not taught in universities. And as you're getting into the industry, you would be, maybe literally on the first day itself, you might be asked to work in an Agile team. Of course, I'm very sure that most of the companies will give you some level of training, but having some kind of exposure through this presentation, hopefully it'll be useful as you're starting to work in the industry. Okay, so let me move on to my next slide, which is the model development lifecycle. So as I mentioned previously, each of these boxes here are these guideposts, okay? Each box here, think of these things as guideposts, and then of course some of these guideposts have been combined together as a grouping that in its own right is a step. Okay, so let's start from here. So for any project, when it starts, you need somebody to identify that here is a business problem that you have to tackle using a machine learning model, because in a business setting, every work that you do ultimately has to translate into some kind of benefit for either our end user customer or to the business in terms of savings, and some kind of tangible benefit should be there. So somebody has to identify a business problem where machine learning can be applied. So that is called the intake process. Okay, so that happens first. And then the second important thing is, okay, now that we know that there is a problem that we can tackle using a machine learning model, do we have capacity to actually work on this? And here, when we say capacity, it is not just whether we have a couple of data scientists to work on this model. It's more broader than that. We have to see whether we have everyone who needs to contribute to this project, which will be the data scientist. It has to be somebody from the line of business has to be available. We need somebody who can advise us on where to find the data, because in large banks like Wells Fargo, we have hundreds of different databases. Data is all over the place. So somebody has to be knowledgeable about these data systems, where they can say, okay, this particular table and these 5 columns are the ones that you will need for what you're trying to model. So you need that. You need somebody like a business analyst who understands existing reports and things like that. So it's a whole host of characters who have to come together. So one has to determine if there is capacity to work on a model. Okay, so that's the second step. Then the third one is, we call this as opportunity grooming, consisting of these 3 steps. And I will talk a little bit about the data science solution design. Okay, so what is data science solution design? It's a process where you try to sort of put a lens on the project that has come through opportunity intake and try to just break it down into a set of logical steps. I'll give you a concrete example here, and I'll use this as sort of the running example as well throughout other places in this presentation. So let's say that you're trying to predict attrition of a product. That is, you're trying to predict which customer will leave a particular product in a bank, like maybe a checking account or a savings account or something like that. Now, so that came in as a project over here. The business is coming to you and saying that, hey, we are seeing 5% attrition year over year. That is unacceptable. Something is really wrong. Can you guys build us a model that can predict which customers are likely to leave in the next 3 months or 4 months this particular product? Okay, so that they can do something about it, right? So that's very clear as a business problem. But you cannot just jump in and start solving the model right away. There are still some questions to ask, right? Like, for example, what does attrition mean in this particular context? It doesn't mean that the customer is actually calling us, right, and telling that, hey, I'm not going to use this product from tomorrow. Maybe that is clear, right? I mean, that's clear that the customer is leaving us. But there could be also other things, like customer is simply stopping to use that particular product. Credit card is a very good example. Some customers will call and say, I don't want this credit card, please cancel it. So that is clear attrition. But some other customers will keep the credit card, but they will not use it. They have just moved on to another credit card that offers them better terms and conditions, but they still like to keep this credit card because they have some line of credit, right? Why should they, call and cancel? So in that situation, we have to infer, attrition as something that either a customer calls and says they're not using the credit card, or they have not used it for X number of months. Okay. So those are some of the fine details one has to actually figure out before they can start going in and building a model. Another aspect is, again, if you take credit card as an example and attrition is the problem, within credit cards, there are there are 20 or 30 different credit card products, each one having different types of terms and conditions and rewards and things like that, which means the behavior of customers are very different in these types of credit cards. Some of them are tailored only for students. Some of them are tailored only for high net worth individuals. So which means these are not one model. The problem is attrition, but there is not one model. So the data science solution design is a step where you really, very purposely look at this model and see, is this one model? How is the actual target defined? And then come up with an action plan in terms of, maybe we just focus on attrition on one specific product and initially build that model out and then slowly expand to others. So that is will be a very sensible way of actually developing the model. So those are all some of the things that one does in the solution design step, and it's a very critical step. Okay. Another step that I'd like to talk about, which you most likely may not encounter in a university setting, is systems requirements. So generally, when you work on a project, you might have your data already quite well prepared, and then the data volumes may not be huge, and because of which you might be able to use some of your standard packages, right, that scikit-learn package, and then be able to solve your model, the modeling assignment that you have. But in a real world setting, some of the things that often happens is there are three dimensions to the data itself. First one is you can have a variety of data sources. You can have unstructured and structured data, and as well as semi-structured data. So all of these things can come at the same time. And you can also have lots of different data tables, from 50 to 100 different tables coming from various sources. So you've got to figure out how to, really join these tables and things like that. But most importantly, you can also have large volumes. If you take credit card transaction data, you can have hundreds of millions of transaction data that you have to deal with in order to build a model. And if you look at log data, that is, if you're trying to look at some customer behavior pattern in terms of, to provide better service, and you're trying to look at, their pattern of logging into their account, or their call history, or their texting history, or things like that, or how they use their apps, that data can be tens of billions of records that you have to deal with. And the traditional things that you do with simple SQL joins and things like that will completely break down. So you got to think about, distributed computing and how many resources that, what is the cluster size that you will need and things like that. And why is that important? The other thing is, unlike, again, a university setting, in real world, there are 100 such teams who are working on their projects. So there are 100 projects that might be going on in parallel. So which means there is always some level of competition, or not competition, but there is competing resource needs. And so it's important for you to make it very clear to whoever is the platform administrator that, hey, I need these resources for me to be able to effectively work on these models, so that those things are secured ahead of time. Otherwise, this can come as a nasty surprise later, that you're trying to build a model and it's taking you 5 hours just to do a single run of training, and you're not going to hit your timelines that you've already committed, around this phase, right? So it's important to be able to, get these things squared off before you get into, the actual model development. Okay. And the next big step here is called the data pipeline development. So again, as I said, there could be, hundreds of tables that you need to put together in order to build a model. And so the first and most important thing you got to do is, hey, how do I join all of these tables and aggregate individual tables in such a way that I can get to this final modeling ready data set? Again, in a university setting, typically you're dealing with an already prepared modeling ready data set in most of the situations, if not all. But in an industry situation, that is very different. So which means you have to talk to a lot of people to understand, what some of these keys really mean, and join those tables properly, and then create this model-ready data set that you can use in downstream models. Another important consideration is the efficiency in which you actually go about doing this, right? You cannot, you come up with a bad design in terms of how you join certain tables. That can cost a lot, because once you're done with models, this pipeline has to be run on a daily basis, or sometimes even in real time, right? When you try to do some of those things, you got to be very conscious in terms of how you actually design this. Efficiency in design is an engineering task, and some of the data scientists focus exclusively, and they're interested in thinking about different ways of engineering these pipelines so that it will be very, very super efficient, so that we can build these models quickly. Okay. Moving on to model development. So now that we have a pipeline fully developed, that is, we have an end-to-end, we have a model-ready data set that data scientists can now use to build their fancy models. It's important to just take a step back and sort of think through the model design. And the reason why this is important is because when you start out building a model, it is important to always think about what is the minimum viable product that I can build, so that my business partner who's paying for this model can quickly use that model. And in order to do that, it's important for the team that is working together to brainstorm and think about how you're going to structure this model, right? So, for instance, when you sometimes build a model, you might recognize that in order to build this model, you may need another model that needs to be developed. For example, you're trying to predict check fraud, right? You're trying to see if a check written is fraudulent or not. And one of the elements in the check is, the signature at the bottom, but then there are also all the other elements, right? The amount, the person who's writing it, and which bank it's being written to, and which bank it's written from, and all of those things, right? But the signature aspect of it, whether it's a legitimate signature or not, is a separate project that can be spun off as a separate project as an image recognition model. And then the score from that model can be used as part of the overall check fraud, right? So those are some of the things that you have to recognize upfront, so that you can plan properly. You can have maybe one data scientist focus on the check fraud, on the signature fraud, and the other people can try to scrap some images scrap some additional information on the amount, and all the other aspects of the check, and sort of build that model, and then they can combine these things together. But if you don't do that planning or design, then again, you can run into some nasty surprises later, where you would wish that you had actually done this thing before, okay? And you might come up with some very suboptimal models that may not perform as well as you wanted it to perform. So that's sort of the spirit of doing a model design before jumping and building the model, which is generally done over here, which is model training and testing. So as you can see, in this overall model development lifecycle, model training and testing is just a small part. It's a very relatively small part. All the other things are super important. So then the next one I'd like to talk a little bit about is this thing called model soft launch or pilot. Again, in a university setting, you're unlikely to actually do this. But in an industry setting, this again becomes super important. And I'll give you an actual example that this will make sense. So let's go back to our attrition model example, right? So we are trying to predict if a customer is likely to leave a credit card product. Now, your model might do great. I mean, you might get 95% accuracy on this model, So you're essentially able to clearly say which customers are likely to leave. But that's not the end of the story. The business has to take your prediction, and they have to take some actions, right? So if they are predicting that Balaji is going to leave this credit card product, the business has to now say, okay, what am I going to do for Balaji, assuming that I'm eligible for whatever they're planning to do, so that he will still continue to use this product. So maybe they will give me better service conditions, reduce the interest rate, or they will upgrade my product, something to keep me in the business, right? I mean, keep me in the book of business. So that is not captured by the model. The model is simply telling that Balaji is likely to leave the bank. So in order to close the loop on this, we have to release the model in a way where the business can actually think of some strategies, and they can test those strategies against those predictions to see if those strategies in combination with the predictions are working, right? And only then we can say it's successful for the business, right? The model can be successful, but if the strategies are not working, then the net result is zero. It's not going to work. Now, it is very prudent to release the model in a sort of a quote-unquote limited fashion without putting the model in full production, because putting a model in full production can be sometimes super expensive. And so so from a business standpoint, it makes a lot of sense for them to sort of take the model results and then test their strategies and determine if it's working before they put the model in full production. So that is the spirit of what model soft launch is all about. Okay. So once the soft launch is done, right? So this is where the business is saying that, you know, we used your model results and we tried some strategies together. It's working really, really well. We are now able to mitigate customers from leaving the bank. It's a positive, beautiful story to tell from a model. Then the model is ready for production or prime time, right? So now the model has to, typically what you'll need to do is to take the model result. So when you build your Python model, maybe the end point of your Python model is a pickle file, or you might even create a RESTful API. That is your model endpoint, right? So essentially, you can put some inputs to your model, and the model gives you an output. So from an academic setting, that is typically the endpoint. But in an industry setting, the long pole in the tent is usually integrating that endpoint to a front-end system. So imagine that there is a model that is going to make some lending decisions, right? So you're going to make a decision in terms of whether you can lend money to somebody or not. And that model is going to be used by, a loan adjuster, right? Or a loan consultant. And they are in their computer systems. And when they enter somebody's name and all this information, the model immediately pops up and gives a recommendation saying that, okay, go and lend this amount to this person. Now, which means that model that you built in your environment has to be integrated somehow where it is appearing in this person's front-end system. And that is a big technology exercise more than anything. And that oftentimes can be quite complex. And so this model production data pipeline thing is something that you'll have to think through and work with the technology partners to help them integrate this model to the front-end system so that the business can use. So that is one aspect of it. The second aspect is more on the data scientist side. And that has to do with efficiency of your model pipeline itself. I'll give you an example. For instance, if you're building a model, when you're training a model, you might have thousands of features, right? You have all of these amazing features that you have created that you're using to make a prediction. And you built this amazing model. And then finally, you realize that the final model only uses 30 of these variables. 30 of these features is what you need to get the best possible model. The remaining 970 variables or features that you used before is not providing any additional lift on the model, which means when you actually put the model in production, you should not be using the remaining 970 features because that's unnecessary coding, right? That could be used in a production environment. If something goes wrong, people will be wondering where things, which part of the code actually broke down. So there is no need to include unnecessary information. So you have to exclude that and rebuild your pipeline in such a way that it's efficient. So that's one. The second one is, suppose you're building something that is more real time. You're building a model that has to react immediately, like fraud prevention or fraud detection, right? Instantly, when somebody is swiping their card, you've got to stop them, right? If it is a fraud. In these types of models, you've got to be careful about how you're even coming up with some of these features. You might come up with some really, really complicated features where you're looking into like 3 years of history and looking at some time trends, and then coming up with these complex features. Just building the feature itself might take you 20 milliseconds, right? But the decision that we need to give with the customer is less than 10 milliseconds, which means either you have to optimize the amount of time it takes to create the feature or the set of all the features within the 10 milliseconds, or you have to make a call that even though some features are really good, you got to actually, sort of drop some of them so that you can be constrained within the service level agreement for us to detect fraud. Okay. So those are all decisions that happen after the model is successful. Okay. And then sometimes we spend quite a bit of time doing that. Okay. So moving on to the last one, which is the model monitoring plan. Once the model is developed and it is in production, that doesn't mean that the model will always keep performing the way it is. Especially in the case of fraud detection, fraudsters are constantly changing strategies in terms of how to skim off the bank or the customers and various techniques that they use. So when these sorts of things are happening, the data, underlying data and the fraud patterns are always changing. So there has to be a system in place where we can observe if there is changes in performance, that we can react to that quickly. So in order to do that, you've got to look at three things. One is the input data itself. Is there something that is changing in the input data, right? And can you sort of put a finger on that and say that this is the data that is changing, and I'm reasonably certain. Sometimes you've got to even do it in a statistically significant way that there is a real change in data. The other one around input data is sometimes not anything to do with the shift in the data, but sometimes there's a problem with data itself coming in, right? There's something happened in the upstream, data processing, and suddenly on that day, you lost like 80% of the data did not come in for processing, which means all your predictions will be thrown off, right? Some of your features are all going to be rubbish. So you got to also figure that out and then make a call to stop the system, fix the problem, and restart the system. So that is also a reason you need monitoring. Then the second thing is around output scores. This is where you're looking at the model's performance itself. Remember that sometimes your underlying data can change, but it may not have a material impact to the performance of the model because, it might be data related to some feature that is not super important. So the model might still be performing quite well. So that has to be recognized and see if the underlying data change, is it really affecting the model performance? And if it is, then you got to react to that. And those are all the things that you do when it comes to monitoring, and it has to be done literally on a daily basis. So you've got to have a team that will monitor these models and be able to take the appropriate actions. So the entire workflow in terms of how you go about doing those things. But these are all things, I wanted to highlight some of these things because these are things that when I was a student like you, I've not done this thing, and I'm talking to a lot of data scientists. I know that it's still not being done, and for a good reason. These are not things that you need to look at it from an academic sense. But as you get into industry, these will be things that you'll be looking into very closely. Okay. This is my last slide around model development lifecycle. So one thing is the process, right? So you've got a set of steps that you have to follow when you build a model. But how do you execute on that, right? It's executed by people, right? I mean, it's by data scientists and engineers and a whole bunch of others. So how do you come up with the right level of organization, the most efficient type of organization that can, help build some of these models in a very robust, agile model, right? That meets the expectations of the business partners. So one of the models that has really worked well is the agile model, and we call the agile pod because pod is just a small group. So there's not an acronym or anything like that. It's just it's got a life on its own because it's been used quite a bit in the industry, but it's really an agile team. But the way we set these things up is there is a core team. Okay, the main objective of agile is the core team that is working on the model should be self-organizing. Okay, you don't need a manager or somebody to come and micromanage. As long as the problem has been very well set up, that is after the opportunity grooming stage, right? When you have a very clear idea in terms of what you need to go after, then we want to empower this team. right? We want to empower the people who are building models, who are hands-on, to be able to take those decisions on a day-to-day basis, because they are the closest, they understand the problem. And as a team, they will decide what are the next steps that needs to happen, and they will do it on a very continual basis. So every day they will meet for about 15 minutes. It's called the daily stand-up. They will discuss among themselves, hey, what are the things that we worked on today? Did anybody face any challenges? So that they can mutually exchange some ideas. And then they go back with some tasks for individuals, right? So they know what each individual has to do, but it's a very collaborative setup as well. So the best way I can put this is it is closely aligned, but loosely coupled, okay? There's very close alignment in terms of each one knows what the other person is trying to do and accomplish, and they have a very good sense for the common goal in terms of what is the next guidepost that they have to hit to and what are the deliverables. But at the same time, they are loosely coupled in a sense. They have their individual tasks to do, right? So it's a very nice environment, very collegial. You share stuff at the same time. You can also learn a lot from the different functions. And typically, the sort of the core pod, right, the working pod, will consist of a senior data scientist supported by a junior data scientist. And again, can be one or many, right? So this is just a representation here. And then we have a data engineer who's essentially a data scientist, but who has slightly an inclination towards working on data and coming up with very good, robust engineering practices on some of the things that I mentioned in my previous slide around the pipeline and things like that. So I would say these three are the core sort of a technical team. And then we will also need somebody from the business side who's able to guide us in terms of the business questions that we are trying to answer using the model, right? Like I mentioned for the attrition, is it, if somebody doesn't use the credit card for 3 months, should we call them that attrition happens, or should it be 6 months? There is no clear science behind that. It is coming from business sense and a strong business intuition. This depends on the person's experience, and so you need a LOB subject matter expert who can guide us through that. And LOB subject matter expert can also help us in terms of how the model will be consumed and things like that, right? So they're also part of this core pod. And then, as I mentioned previously, data can be scattered in like hundreds of, maybe 50 different databases. You need somebody who can tell what is the right table and the right columns in these tables to bring in so that we can build our models. To give you a concrete example, in the banks and other financial services, you can have a table with 50 different columns called revenue underscore this, revenue underscore that, or something like that. Which is the right revenue number for us to use for the model? Data scientists cannot make that call. If we try to make the call and try to guess something and bring the data, we build all this model, and finally somebody says, you know what? Either the model is not performing well because we chose that wrong variable, or the model is performing great, but we chose the wrong variable, right? So both sides can hit us. So it's important to have this data subject matter expert who understands the business context in terms of how these data sources are used by these business areas and can advise us in terms of what is the right source to give. Okay, so they take accountability for that. And if you run into any data challenges while we are working on the model, they can also help us come in and bring any additional data sources that we'll need. Okay, and also we'll also need somebody to do the test and learn. As I mentioned, for most of the models that we build, oftentimes when not, we will need a companion strategy that has to go with the model, right? So the test and learn person has to start thinking from day one. Okay, when this model comes out, what will be its model form? And how do I actually come up with these strategies to mitigate, attrition, or in case we are trying to get new customers in, what are the messaging that I need to send? If it is a marketing campaign, what kind of messaging do I need to send so that the customers will come into the bank? And if it's a recommender system, right, like a next best action and those types of things, what are those critical messaging and product recommendations that I need to think about so that this model's effect can be fully leveraged for the business, okay? So that's the core pod. Now, the pod is supported by an outer pod, right, which we call as the support pod, and the data science manager typically sits in the outer pod. So this is a new structure, right? So managers are not anymore, we don't want managers to be micromanagers. We don't want them to be sitting and telling every day what to do. That's not the job of the managers. Managers will be managing like 5 or 6 these types of pods. We want to have a considerable level of independence in these core teams, and that is the way they operate. They give an update to the manager just to seek advice, and if there are any kind of escalations, for instance, right? Sometimes it happens. The LOB SME doesn't show up for these pods, or they're non-existent. Suddenly, they're not available. Then, this team, these guys have to, focus on building the model. So they will let the manager know and say, hey, we are having this challenge, and the manager will be able to escalate that up to whoever to be able to address some of those challenges. So that is the role of the data science manager. Of course, they can also give some technical guidance here and there in terms of course correction and things like that. But overall, they will be in the outside pod or the support pod. Another core function is an agile coach. So we are following an agile model. In some areas, people use a scrum master, right? A scrum master is somebody who will sit within this core pod, right? They'll sit within this core pod and advise on a daily basis how to run the scrum sessions. Our experience shows that is not needed. All we need is this team collectively needs to have good training on agile methodology, and they're very good at actually following some of these things. And although they're new to agile, having a coach to occasionally sit in some of their agile sessions and be able to give them the right level of direction over a period of time reinforces some of these agile concepts really well, and then they start performing in peak capacity from an agile standpoint. So we have an agile coach outside as a support pod, and in some industries you might find that they might have the agile coach or the scrum master here, but this is a structure that we follow at Wells Fargo. So that's all I had for model development lifecycle. So before we move on to the workshop, any questions from the audience?
You mentioned that banks often collect data with respect to message logs or call logs to kind of build their models. So while I'm just curious to know, while doing so, how do they ensure the privacy and where do they get that data from?
Yeah, very, very good question. So privacy is very important, and I'm glad you asked the question because when we use this data, looking at phone numbers, text messages and things like that, our job when we build a model is to focus on just the content there and we should not know who that person really is. So when we work on these types of models, there are different classifications of data. There is something called sensitive data. There is PII, which is personally identifiable information, and then a whole bunch of different categories there. Okay, and what we do is we are very careful about this. So when a project starts and the data SME is saying that here are some of the data sources that you can get, there is a legal risk and compliance officer that we have to work with. And they have to first clear all the data before we can start using it. That's the first one, okay? So they will ask questions as to why you need this data, right? What can you do without this data? Like, for example, when we are using a log data to sort of see, okay, based on this pattern, if I have to send a message to this person, should it be by email? Typically, that's what we use, right? I mean, we say, okay, what is the best channel for us to reach this customer based on the patterns that we have seen? Suppose for some reason we are using social security number. Obviously, that's not required. And nobody should use that. Nobody should ask for that. But if they ask for it, the legal compliance officer will ask, why do you need this data element? Should not be using that, and that will be excluded from that. Okay, so that's one. Second thing that we do on our side, as a leader in this organization, is my responsibility. I take on a lot of responsibility in terms of how my team actually takes in data. So we have our own internal processes. For instance, we never take customers' first name, last name, address, or any of those things. What we generally do, and this is from a modeling setting, usually that is sufficient, is to just take an ID. So an ID and the text message is sufficient. We don't need any other information, because any other thing that somebody has to do downstream, they can join that information with the person's first name and last name, and if they have to, directly interact with the customer. But from a modeling standpoint, we usually obfuscate all of that information. We filter out all of those things so that we are only working with the data that makes sense for that particular modeling effort. This is going to be really a mini workshop. Okay, so normally when we conduct this workshop, in fact, in January, we are doing one in Georgia Tech for a week. We are calling that as a project week. So we usually introduce this along with some data so that we essentially have the students experience the full model development lifecycle over a week, and sometimes this is also done during an internship. So thanks for your patience. I'm going to sort of compress this into just 30 minutes or less, but hopefully it'll give you a good experience in terms of what data science solution design is about. So let me just describe this problem statement. So health insurance companies, right? When you try to get a term life insurance from a health insurance company, and you're trying to get a quote, right? Just to see what you're likely to pay, they will ask you for your height and weight, and using the height and weight, they can calculate your body mass index. And if the body mass index is high, then what they would typically do is to charge you a slightly higher premium because you pose more risk, right? Because that is an indication of the health, your health at the time of signing up for an insurance, term life insurance. But the challenge with this is when somebody actually shares their height and weight, it's a self-reported value, right? The insurance company just trusts that because they're just giving you a quote. And because of which, because it's self-reported due to conscious or unconscious reasons, these heights and weight that customers provide typically tend to be wrong. And because of which, insurance companies give the wrong quote. They give a quote, they might say it's $900 for a year for a term life insurance for $500,000. And then when they actually bind the policy, which means at that time they actually have to ask you all the questions. Not only questions, they'll send a nurse to your house to take your height and weight, blood draw, and all of those things, so that they have a very accurate picture on your health risk. Then at that time, they might discover that you have a lot of health challenges, and it goes up to $1,500. That is not a good customer experience, right? The customer thinks they're going to get $900. After like 2-3 months, they come back saying that, hey, after doing all of these things and reviewing your numbers, including your height and weight, we think that you should be $1,500. It should be $1,500. And so we're trying to avoid that, right? So we want to give a quote that is as close to what it would be when the policy actually binds. And in order to do that, we want to make sure that the BMI that we are predicting is as accurate as possible, right? So that this mistake, because ultimately height and weight is used for BMI. So the case study here is to see, is there another way for us to determine the BMI that we don't run into this risk, right? So, so in this case, the insurance company, just imagine that they've hired you to come up with some kind of image-based solution for you to determine accurately if somebody has a high BMI or not. So how would you go about doing that? So that's so imagine that you're working on this problem. So think of this as that AI intake, right? This is that intake. At intake, you're going to get a problem statement like this. What would you do for data science solution? How do you break this problem down? Ask the right questions and develop more clarity on this. Okay. Any questions? Any clarification that you need about the problem statement?
I mean, I don't know if it's appropriate, but can we add some data as development of working on that problem? I mean, can we request adding data?
I mean, we're working on it now. You mean so right now for you to?
No. What I mean is, if one of the ways of solution to that one is to ask for specific data that will help us to improve the accuracy.
Yeah, of course. Yes. Yeah, make those assumptions, right? Obviously, it's an image-based solution, so you'll need some images, right? Yeah. So you can make those assumptions. Did that answer your question? I'm sorry. My understanding is you're asking if as we think about solutioning this, can we assume that we can get some data from customers?
Yeah, I mean, like, is the task trying to identify BMI from what we have, or we can ask customers about some specific information that they can give us that can help us identify the right.
So remember, these are not customers yet, right? These are prospects. So they are not yet customers. So you don't have any information about this person. They are interested in becoming your customer, and they're asking for a quote. So you don't have any information. So you'll have to collect. In a full workshop, what we normally do is we don't really put these key considerations. We just have go through some of these things through each group and have you guys, talk about how you went about solutioning this. But here I have created some cues, if you will, so that we can direct some of our questions. Unfortunately, because of the time, I'm not sure how many of these key considerations we can discuss today. But let me start with the first one, right? And maybe the first group, it will be great if you guys can share, what kind of image-based solution did you think about for accurately determining BMI risk?
Yeah, we were talking in our group about that. That's going to be the optimal way for determining BMI, because you don't even need to have actual height numbers and weight numbers. You can just determine from the picture. You can determine if it's overweight, underweight, if it's in between some restrictions. But there is question, when was that image made? I mean, the time. And also, is it fair? I mean, is it your picture, like the customer picture, or it's picture from internet somewhere?
Yeah. What kind of image? When you say image of somebody, what image did you have in mind?
We were talking about several ways. So we can ask person to make a picture in front of mirror, like something like that. Or you can ask customers to allow you to use social media pictures, where customers just use their own pictures. Or you can try to use like a picture of like driving license picture, where you have a face and you can try to predict what's the fat percentage of that person.
Okay. No, all those things are valid. So driver's license pics will not work for precisely the reason that you just mentioned about, people take driver's license pics much earlier. It's not generally the latest and greatest. So very difficult to sort of use that image as well, just from an imaging standpoint, in addition to other challenges. Now, getting a full body picture is going to be almost impossible, and it hits on a lot of different problems. Okay, so and I would put social media pics difficult from a technology standpoint. If you have looked at CNN models and other things, social media pictures come with so many different kinds of backgrounds, so many different angles and shades and things like that. Makes it almost impossible to use social media pictures to the extent that you want to predict, sort of the risk of BMI, right? So, did anyone think about selfies? Just the face.
Just face. Yeah. The thing is, like, the mirror picture, taking pictures in front of a mirror or making selfies is what I was trying to say. Something like that.
Okay. Got it. Okay. Yeah. So selfies, I think, would be something that is certainly, it's still an image of a person, but it's less personal in some sense. So more people will be comfortable, sharing selfies. So which is what I think, this is of course a project that my team has worked on before. So I think selfies is where we sort of zeroed in on. So maybe, so those are great. Any other thoughts from anyone? in terms of image-based solution? What could be that image-based solution?
We talked about the selfie solution as well, just because it's a lot easier for customers to do. Like you said, rather than trying to get a picture in a mirror that contains your entire body, you might even need someone else to take that picture. But everyone can hold their phone at arm's length away and take a selfie.
That's right. Yeah. So let's maybe move to this one. Okay, now that we have zeroed in on the fact that, hey, we will use a selfie to make a prediction, what would be the prediction? So what are we trying to model here?
Yeah, that's the thing. What we were talking. Are we trying to predict the correct BMI, or trying to predict? Because the weight to height can be different. I mean, there can be same weight to height, but there can be the weight which is mostly fat, or it's muscular, and it will not be represented in BMI at all. And that's a completely different factors in health conditions.
Right. Predicting the exact BMI. I'm sorry, because of the time, I'll have to just rush through some of these things. I wish we could spend more time getting all different points of view. But just wanted to quickly share that, yes, I think predicting the actual BMI number using deep learning model, any kind of architecture is going to be a very difficult problem. The actual numerical value using just the picture. But where it's effective is generally because from an insurance standpoint, I think the insurance company is not concerned about what is your exact BMI. Is rather concerned about whether you have a high BMI or not. And usually they have a cutoff of 27 or 28. If you're above 28, then you're considered to be obese. I think 28 or 30, something like that. So then if you're below 30, so the concern is more on whether somebody can be considered as obese or not. And if you make it a more of a dichotomous problem where you're predicting whether it's a high BMI or low BMI, it makes it more easier and also works from a business standpoint. So this is again, one of those things where you'll have to consider as to, what is the right approach, right? Where you take an approach where from a modeling standpoint, it could be more accurate and it also works for the business. So that's, that's one. Second thing, yeah, sorry, go ahead.
Yeah, and
please.
One of the things that we were trying to implement first, as trying to compare that to car insurance, when the car insurance companies, they offer you to install special equipment on your car for first month.
Yeah.
That we cannot. Health insurance company can also offer to wear some wearables like smartwatches to wear your pulse, which will also give much better prediction of your health condition than just BMI.
Yeah. Yes, I agree with you, but that might be more on an ongoing basis. So remember that this problem statement is about not an existing customer, but the prospect, right? So you're just, trying to get a customer in the door now to send them a watch and then for them to share some personal data like that. It's going to be very, very difficult. Not impossible, but very difficult generally for customers to share that kind of information just to get a quote. In the case of car insurance, you're absolutely right. Telematics is a very big thing, but there the customer is getting a discount if they drive well based on the behavior patterns of their driving, right? In the same way, for health insurance, people have tried this thing where they say, okay, in exchange for you sharing your health data with us, we will give you a discount if you are keeping good health, okay, under certain quote unquote parameters, right? It's got mixed results in terms of privacy and things like that. Remember that the way term life insurance works is once you sign up for a term life insurance for $500,000 or $1 million, from the very next day, you can go on a ice cream eating binge. Nothing, right? Nobody can stop you from doing that. So the insurance companies have to give a discount so that they are mitigating that risk. But it's a good idea. But it happens after somebody signs up for an insurance. But this problem is about before. So there, unfortunately, it will be difficult it will be prohibitively expensive for the insurance company to send out something like that just to get a quote, just to give a quote. So since the problem is about predicting, different levels of BMI, then the question becomes, how are we even going to build a model, right? In order to build a model, you need to get data. How are we going to get data for this? So we need a lot of selfies, right? And we need ground truth data. That is, we need selfies along with somebody's height and weight. How do we go about collecting the data to build a model? And you'll need hundreds of thousands of these images in order to be able to build a model. Anybody thought about that as to, or any ideas in terms of how one can go about collecting data?
We can just run some company that's giving some, as you say, maybe some incentives to people to correct their correct BMI, I mean height, weight, and make the picture.
Hospitals don't have they don't have pictures. They might have height and weight, but again, remember that this has to this is of course for building a model. You can try to get data from some companies, but it's difficult data to collect. So this is where sometimes when you do solution design, you got to think out of the box here. I can share, because it's not proprietary information, that what we did, and this came not from a data scientist, it came from a strategist. And this is where that Agile pod structure is very helpful, that they have no idea of data science, but it came up with a brilliant idea, controversial a little bit, but nevertheless, it's a legit idea, legit thing to go and get data, is from the prison population. So anybody who goes to prison, right, who's charge sheeted and goes to prison, you have to take their close-up photo, and their height and weight is recorded, and very accurately so as well. And so that is a good place to get a lot of data. Some states release this publicly, right? You can use that to actually build a image. The problem there is you do have some bias. As we all know, the prison population in the US is very imbalanced, right? I mean, it's like, you have a lot of African Americans incarcerated in jails. So you do have that bias. So then in order to correct for the bias, you still have to collect some samples. There you can actually do a sort of a selfie drive, right? What we did was in our company, we actually had people volunteer. There was a form that they had to fill that, they don't have a problem and all those things that legal people, the legal team had signed off on. And we gave them a Starbucks card, right? We gave them $20 Starbucks coupon to come and, take a selfie. So it helped them. They got a reward, but also they signed off on this thing. And we only used this for training. And then we, of course, destroyed the data. So there was all these clear conditions written in order to take care of the bias. Okay. Now, that is one type of bias. Then another type of bias that comes in is based on the medical condition. I think one of you actually briefly mentioned that, is athletes, right? They tend to have really, really high BMI, but they're very super healthy. Okay. The muscle mass really makes up for that. So in order to compensate for that, again, a very creative idea came from somebody who was not a data scientist. More reason to actually include a diversity of skills when we build models is to use as athletes, right? From NFL actually publishes all of the athletes' photos and height and weight. And you use that data so that that certain types of images can actually point to higher BMI, but they may be healthy. So you can exclude those types of populations. So that was also used to improve not only the accuracy of the model, but also the fairness, right? It has to be a fair model. So it brings in a couple of things. One is to be creative in terms of how you go about sourcing data to build a model, but also it also looks at how it also reflects on the fairness, ethics, and all of those questions. That I've sort of, answered a little bit on this aspect. Any other thing that you can think of over here? Let's maybe talk about appropriate end-to-end design from a technology standpoint. When you have this kind of a model being used in practice, what could be some challenges?
It's not very clear the question itself.
So let's say that you've trained a model. The model predicts really well whether somebody is having a high BMI or low BMI. Now you want to put this in production, right? And so that we can have this be used by the insurance underwriter. So when a customer calls, we tell them, hey, send me a selfie, and then I'll give you a quote. So that's a high level design, right? So how would we operationalize this design? Any challenges in terms of making this a reality?
So the
So this
image
is also a little
itself,
bit on the UI UX question. Yeah.
the image itself can be very challenging because of just you can just right now watch in my video and you can see that light itself is not very good. So the quality of pictures can be challenging. The number of objects can be challenging, and also the fairness, the authenticity of the picture, because person can tell that, hey, it was me, but then he asked his healthy friends to make that picture.
Yeah, authenticity. Very good point, right? Because it's just a quote and we're not binding on that, authenticity of the picture, can be in some sense overlooked a little bit because it's not posing any risk to the insurance company. Yeah, you take a picture, if it turns out to be that's not the same person. Finally, when the nurse goes, right, after 3 months to just make sure that all the numbers check out, they just reject this, right? And there'll be a right to reject that. And the assumption here is most people are genuine and, they don't cheat, right? So this is not going to overly impact the business. But the quality of the pictures is a very super important thing. So if you simply ask somebody to, just click, a selfie and then send it, they will take all kinds of selfies. So it has to be something that has to be directed, right? It has to be a selfie that is directed, where it must be through an app that tells them exactly how to take the selfie based on all the lighting conditions and so on, so that when they send that thing, it's good. And that poses some challenges. Will a customer actually download an app just to get a quote? I mean, suppose they're trying to get a quote from 5 insurance companies and each insurance company has their own app. They're not going to download 5 apps, let alone even a single app, right? Yeah. So it has to be a web-based solution. So the insurance company has to be a web-based solution that will still be able to take a picture, and those things can be done. Another thing along with the same thing is the quality of pics and how fast you turn around and give them the BMI, right? You need to be able to run this CNN model. Scoring should happen instantly. Now, if you take the picture, it gets uploaded to a server, and then the CNN model interrogates that picture and then sends them back a quote. It might take like 5 seconds overall. Not that the CNN model itself is taking time, but just the technology infrastructure, right? Overall. That may not be a good customer experience. In order to give an instant quote, ideally this model should live on the edge meaning on the device itself. So that's another thing as well, that how do we go about doing that? Those are all some challenges that are pretty open. Getting it on the, deploying this model on the edge is not simple.
Sir, I think we are running out of time. We are running out of time.
Oh, yeah, sorry.
Another 4 more minutes. If you wrap it up with the job opportunities, and we can close our discussion today.
Okay, sounds good. Sorry guys, we are rushing through a little bit today. But yeah, if you have any questions, do ask Srini, and then I'll circle back with answers. Okay. So just want to quickly go through opportunities at Wells Fargo for a quant job. See, the quant program is an entry-level quant job. So within Wells Fargo, we got about 6 model development centers of excellence, including the one that I work in, which is the AI Center of Excellence. But then there are other centers of excellence, like Mortgage Center of Excellence, Trading Center of Excellence, and other centers of excellence where we build models. And anybody hired into those centers of excellence is considered as a quant. And we have a program for that, where somebody entering the program will go through a rigorous training, and then they will be assigned a mentor, and then you will get to do a rotation for 6 months in 2 different, 2 of the 6 COEs. And then after this 1 year rotation program, you will decide which one works out best for you, and you'll start working full time in that particular COE. Okay. So it's a very exciting, quant program. It's for both masters as well as PhD students. So I'm going to skip this a little bit given the time. So just go directly into how you can apply, and I'll send this information to Srini. So you still have one more day to apply for this. So don't worry about this credit and operations risk and things like that. If you're interested in AI specific jobs, right, you can apply to this track. If you're interested in capital markets track, again, capital markets is all about trading and things like that, trying to look at macroeconomic risk and forecasting, trends, mortgage risk and things like that. Sorry, I don't have a lot of time going through this thing, but I would say if you're interested in AI falls under this track, okay? So apply for this. If you're a PhD, then you use this job code. If you're a master's, use this job code. So the initial interviews, first round interviews will start around November 15th, and then we'll have another round, the third week of January, and then we'll make decisions by early February. And in terms of visa sponsorship, we sponsor visas only for PhDs. For masters, we do not sponsor visas at this point. So just wanted to, give that information to you. And I also have some contact information. Her name is Shasta Cornelius, and you can certainly email her, reference my name. And if you have any questions, you can certainly ask her as well. But I will share this information with Srini, who can distribute it more widely.